Hello there. Um, this is the last section we're covering before exam 3. Um, and it is a little out of order, but this is 5.5 in the book if you're looking for it. And we're going to talk about solving equations that involve square roots, basically. And also, this is something conjugate terms come up not so much in 144, but in 170, which is Cal 1. If you ever decide to go on, you will find them very useful there. So when we have equations with radicals, it can be cube roots, can be square roots, call them radical equations. And one of the primary ways we solve radical equations is using this thing called property 5.5. It's saying here that if two numbers are equal, um, then you can raise them both to the same power. So a cubed would equal b cubed. Well, so if we have a square root of some number that equals another number, can we square both sides? That's the question. What is the square root of a squared? Well, that would be a. So is this always true? Well, let's look at this example 1. We want to solve an equation involving a square root. So what we're going to do is square both sides, because why? That gets rid of the square root signs. So square both sides. It says it right there. So what happens when you square a square root? Basically, that radical sign goes away. So we're just left with 2x minus 5 on one side and 49. Then we solve for x. We find that x equals 27. Well, does that work? Let's check. If we plug 27 in there, 2 times 27 minus 5 equals what? The square root of this number. Well, what is 2 times 27? That's 54. Square root of 54 minus 5, that is the square root of 49. It does indeed equal 7. Since it resulted in they're checking it for us, a true statement, that is the solution. X equals 27. So we will raise both sides of an equation to a positive power. And sometimes we will get extra solutions. And this is this funny word that you'll hear, extraneous solutions. Watch out for extraneous solutions. They are solutions that you get when you square both sides, but that don't satisfy the original equation. And we'll see some examples in the homework. Now, before we get to those examples, I want to talk about conjugates. If you remember the difference of two squares, we can always factor this as a plus b, a minus b. And the middle terms of FOIL, if we go the other way, those middle terms, they get canceled out when we have the difference of squares. So this pattern can be useful if we have to rationalize a denominator involving square roots 1 or 2. So let's see how we would do this. So for A, I have 4 over 1 minus the square root of 2. So here's the trick. The conjugate of 1 minus the square root of 2, this term, is 1 plus the square root of 2. The only thing we change is the sign in between the two terms. It's a binomial term, and so we're going to multiply by the conjugate, 1 plus the square root of 2. And if we do that on the bottom, of course, we better do that on the top so that we're multiplying by something that's equivalent to 1. And I'll just go ahead and put this in parentheses. So what happens when we multiply this out? Let's get rid of that. Okay, so let's look at the denominator first. If we use FOIL, soon you'll learn the pattern. 1 times 1 is just 1. First, outer would be plus the square root of 2. 1 times the square root of 2. Inner would be minus the square root of 2. And last is going to be, let's do it down here, minus square root of 2 times square root of 2. What do you think that's going to be? Well, 2 times the square root of 2 is 2, so this is minus 2. Now, what is nice about this is the outer and inner terms canceled each other out. And of course, we still have to deal with this numerator. We just multiply 4 times 1 and 4 times root 2. So what are we left with at the end of the day? 4 plus 4 times the square root of 2 over 1 minus 2, which is negative 1, which we would probably write as negative 4 minus 4 times the square root of 2. This expression divided by negative 1 is the same thing as this expression times negative 1. So the conjugate is obtained by changing that sign between the two terms. And the relationship to our pattern here can be seen. We have a plus b times a minus b just gave us the square of the first term minus the square of the last terms. So that was the square, in this case, the square of 1 minus the square of 2. And that is what we ended up with, 1 minus 2. So let's do the next one. On the next page, we have 3 over the square root of 5 plus the square root of 2. So what's the conjugate of this denominator? Well, all we do is change the sign in the middle. So let's multiply by the conjugate. So I'm going to multiply by the square root of 5 minus the square root of 2. And I have to do this to the numerator as well. Parentheses will help us keep things straight. So we're multiplying by something that's equivalent to 1. So what happens? The pattern tells us when we multiply these two numbers, we should just get 5 minus 2, because the middle terms are going to cancel. So we get 5 times square root of 5 times square root of 5. That is just 5. And square root of 2 times the negative square root of 2 is minus 2. And in the numerator, I'm not multiplying this out just yet. Let's see what this turns into. What is 5 minus 2? Isn't that 3? So my final answer is square root of 5 plus, nope, my bad, minus the square root of 2. How odd is that? That's what this is equivalent to. All right, so here we're just asked to find the conjugates and multiply. So I'll write this down. Then we're going to multiply by its conjugate. All we do is change the sign in the middle. And our pattern says it's just going to be a squared minus b squared. This is a, this is b. So what is the square root of 2 times the square root of 2? 2. 5 times 5 is 25, but it's negative. 2 minus 25. And so this equals negative 23. So this is just illustrating how we multiply when we have radical signs, and what the conjugate does for us is it gets rid of the square root. It can be very useful in that way. All right, let's do x plus the square root of 3. Multiply this by its conjugate would be x minus the square root of 3. And just based on the pattern, I know this is going to be x squared minus 3. If you work it out with FOIL, the inner and outer terms cancel each other out. The inner term is x times the square root of 3. The outer term is negative x times the square root of 3. And what's the last one? 4 minus the square root of x minus 2. All right, be careful here. What is the conjugate? The only sign we change is the one between the two terms. Now, our pattern tells me it's just going to be a squared minus b squared. A in this case is 4. B in this case is the square root of x minus 2. So what is a squared? 16. What is b squared? Be careful. It will be in parentheses, x minus 2. So my final answer is going to be something minus x plus 2. This is 18 minus x. So these are just examples of finding the conjugate and how the conjugate works. Now, in part 2, we will solve some equations. We'll work these problems from your homework.